Hello and welcome everyone. Myself Dr. Supriya Gupta Bani, Assistant Professor of Ramdev Baba College of Engineering and Technology. I am here to present today's topic, that is template matching for object detection. Let's begin with the topic. What is template matching? Template matching is an image processing technique which is used to find the location of small parts template of a large image. This technique is widely used for object detection projects like product quality, vehicle tracking, robotics, etc. In this article, we will learn how to use template matching for detecting the related field in the document image. When we are going to use OpenCV template matching, that is again we are using the Python code for template matching. Your template slides pixel by pixel on your image. For each position, a similarity metric is computed between your template image and the part of the image it recovers. Clip, crop, field image from the main document and use them as separate templates. These are the basic approach that how we are going to use the template matching technique. Define tune threshold for different fields, then apply template matching for each cropped field template using OpenCV function. That function is cv2.matchTemplate. Draw bounding boxes using the coordinates of rectangles fetched from the template matching. Optional augmented field templates and fine-tune threshold is improved result for different document images. Now, it's simple to implement requiring only 2-3 lines of code. Template matching is computationally efficient. It doesn't require you to perform thresholding, edge detection, etc. to generate a binary image such as contour detection and processing this. And with the basic extension of template matching can detect multiple instances of the same or similar object in an input image. In your input image contain these types of variations. You should not use template matching. Utilize detecting object detectors including HOG plus linear SVM, that is support vector machine, faster RCNN, SSDS and YOLO, etc. Template matching is a technique that digital image processing for finding small parts of an object that matches a template images. It is a much simpler solution than a neural network to conduct object detection. In addition, it comes with the following benefits. The first one is no need to annotate data, a time-consuming and mandatory task to train neural network. The second one is bounding boxes are more accurate. Third one is no need of GPU. The fourth one is, in my experience, combining a neural network like YOLO4 and object detection with template matching, here is a good way to consider improve your neural network performances. Now, the advanced using template matching advantages are going to here. Computationally expensive. This is a little bit expensive with the computationally expenses. Easy to use and modifiably for different use cases. The third one is give good results in case of document data scarcity. Where we have a large amount of data, it performs very good and very well there. Now, here in the figure, we can see the input image and the output object which have to find from that input. So, we are going to combine that, or we are going to train our model that where is the cup in that images. So, the cup is your template and you have to match this template with this image. we have to train multiple cup designs for the pre-trained model, and then we compare that yes, if there is in image any cup is acquired, so that image can be detected as template matching. So whenever we combine this template to the image, yes, we have find the square, green square is a cup. Yes, so we have done the template matching with this formula. Template matching can be seen as a very basic from object detection. Using template matching, we can detect object in an input image using a template containing the object we want to detect. Only that template are going to use for your object or your required object. Essentially, what this means is that we require two images to apply template matching. First one is source image. This is image we expect to find a match to our template in. And the second one is template image, the object patch we are searching for the source image. So these two images are required for template matching, that is source and template image. To find the template in the source image, we slide the template from left to right and top to bottom across the source. Then we have find that where is the template is matched with the given input image. So the left to right and top to bottom approach is better approach, that's why we have to cover all the surface area of the image to finding our template. Again here we can see the image is going to approach the left to right and bottom to up. When we are using left to right approach, first approach will be failure because the cup is inside to lower part. Then we are going to approach up to down. So in the second portion or second patch, we find the cup in the middle of the section of the image. So this procedure is going to use the template matching technique. Now OpenCV, whichever use for template matching, and the Python basic library for image processing comes with the function cv2.matchTemplate for performing this template matching. The function takes the following arguments. First, image, the larger image where you want to search for the templates. The second one is template, the template image that you are searching for. Third one is method, the comparison method to use. There are several comparison methods available where we are using this template match models. The function then returns a matrix that contains the comparison results. Each element in the matrix will have a value that indicates how well the template image matches the region of the larger image. Let's see how this works in practice. Create a new Python script that would be name of template_matching.py. That is my file name. You can consider every another wording for this and copy the following code into it. This is the code where we can use the import cv2, where we are going to use this OpenCV for template matching. Then we are going to load the original or input image with image cv2 image with JPG. The second upload is your template, where cv2 template is again in the JPG format. So in this way we are going to load two images, that is your basic input image and the second one is your template image. Template image means whatever object you want from your image. Now we can see that our main input image, if we are going to use as RGB scale, means it is grayscale values 0 to 255 conversion required, then we have to convert this image into grayscale image. BGR images are the colored image and the grayscale images are converted to 0 to 255 grayscale values that belongs to 0 black and 255 is white. Template matching. The first step is to load the main image and the template image. We then make a copy of the main image, convert the two images to grayscale and get the width and height of the template image. Then we perform template matching using the normalized cross correlation method. The result of the template matching is a matrix that contains the comparison results. The matrix has the following dimensions, where we can see the width is image height, template height plus 1, whereas height is image width, template width plus 1. These are the basic matrix of width and height of a template which are you going to use to match with the original image. So the next step is to find the location of the best match with the input image. This can be done by using cv2.minimum-maximum-location function. This function returns the location of the minimum and maximum values in the matrix along with the minimum and maximum value themselves. It means this minimum maximum location find that where your template is matched more and more level in the input image. So here we are going to use this minimum and maximum location with CV2 min max location. This function is going to perform your location from left to right and top to bottom. So we can see here that the process of matching the template from the input image is going to process with left to right and bottom to up with 0 to 255 grayscale level images. So here we are using the CV2 min-max location function to find the location of the maximum value of the result matrix. Next, we extract the top, left and the bottom right coordinates of the rectangle that will be drawn around the best match. The green boxes you have plotted that would perform with this top left and bottom right approach. Finally, we draw the rectangle of the copy of the main image and display the image. Let's test our code and see how it works. Here is our example image. In this image, we can see a bucket or a basket with very much of where you are giving the cat images. And what is your template image? The brown cat is your template image to finding this on the input image. So we are going to process this all code for this similar image and we are going to match this brown cat image from the template. Whenever we have applied this template from this image, we have to process from left to right and top to bottom approach. After applying this template approach and finding the minimum local and maximum local, we have defined that this green square finding the maximum matrix location with this template matching in the input image, and finally we found our template in this input image. Yes, the brown cat is exactly matched with your input image. The another example is we have to find this Coca-Cola exactly in your given image. When we are going to find this template with your input image, we can see the left to right approach and bottom to up approach is going to process and finding the maximum matrix with this input. You can see that this blue area of rectangle showing your exact template, that is Coca-Cola, is present in your input template. Yeah. What if we want to detect multiple instances of the same object in an image? In this case, we need to make some modification to our code. In our previous code, we are only getting the location of the best match. We can modify our code such that it will get the location of all the matches that are above in the certain threshold. Let's see how to do it. Create a new Python script, name a multiple template matching.py. Multi-template matching means we are going to use our multi-template for comparing the input image, and copy the following code into it. For finding the multiple template in your input image, again we have to perform the same process. We have to go with the left and right and top to bottom approach. We have to find the grayscale value 0 to 255, and we have to make the matrix multiplication here, and we have to find maximum matrix matching with the template and your input image. Firstly, we have to convert your template in grayscale image, your input image also in a grayscale image, and then you have to understand how much template you are using for it. If you have 2 or 3 template, you have to name their templates like template 1 to n. So, here we are going to use multiple template matching in your input image, that you have to find multiple objects in a single image. The code snipped above is almost the same as the one we used in the previous section. This time we are importing the NumPy library and setting the template matching and non-maximum separation thresholds. We will use NumPy to get the location of all matches that are above in the thresholds. Here we set the non-maximum separation threshold because we want to avoid detecting the same object multiple times. Let's now filter out the location of the matches that are above the threshold. Here in the code, we have to define the coordinates of x and y coordinates to finding up the different types of template with your coordinates. If you have multiple templates, you have to convert the image into grayscale level 0 to 255, and you have to define each and every template's height and width. Using the npwhere function, we get the xy coordinates of the matches, then the greater than our threshold. Then we loop over the coordinates and draw the boundary boxes and a copy of the main image. Finally, we display the image. Here are the image and the template image that we will use for multi-template matching. As here you can see that the goal is to detect all the small white cubes in the image. Let's run our code and see how it works. Here you can see whichever template you have provided, that height and width can optimized with the input image, and all the small white squares are detected as it is in your input image. As you can see, our code was able to detect all the small white cube in the image, and if you check your terminals, you will see that the number of matches found in 5. Let's try another example. Here are the image and the template images. Again, our goal is to detect all the circle that is white in the image. Now here we can see all the white circles with the similar height and width are detected with the green boxes. As you might have noticed, the small white circles aren't detected. This is because template matching fails to detect objects at different scales. Also, if you check your terminal, you will see that the number of matches found is 8. This is because the same object is detected multiple times, meaning that different locations refer to the same object. To avoid this, we can apply non-maximum separation. It not will go to detail of NMS, that is non-matrix separation here, because it is out of the scope of this method. Simply put, Non-matrix separation is a technique used in computer vision to eliminate redundant or overlapping bounding boxes that are detected by an object detection algorithm. Here again we can see that boxes are creating with their template height and width matching, and indicates that whichever height and width you are going to use for your template, that is matched with your input image. OpenCV provides a function called cv2.dnn NMS boxes that can be used to perform non-maximum separation. Let's see how to use it. First, we create a list of boundary boxes using the coordinates of the matches that are greater than the threshold values. After getting our little list of boundary boxes, we apply non-maximum separation to them using the cv.dnn.nms boxes function. The function takes the bounding boxes, the score, the threshold and the non-maximum separation threshold as arguments. The sources are values that are returned by the template matching function result. We just need to get the score of the matches that are above in the threshold. In the above code, we are doing this by using result y, coordinates x coordinates expression. Here we are finding the non-maximum separation multi-template matching matrix finding. Here we can see the different type of scores of matrix to apply the maximum matrix application of your input image. The threshold value arguments is not very important here because we have already filtered out the matches that are below in the threshold. The NMS threshold argument is the non-maximum separation threshold. We have already set this threshold to 0.6. The function returns the indices of the boundary boxes that survive the non-maximum separation. So, for example, in our previous example, we have 8 bounding boxes which are applying after this non-matrix non-maximum separation. We will get this list of indices. Here the matrix is 2, 5, 1, 4. So, the bounding boxes that survived the non-maximum separation, we can use these indices to keep only the bounding boxes that survived the non-maximum separation. Here in the image of code, we loop over the indices and draw the bounding boxes on the main image. The result would like quite similar to the previous one. Now, we can see that if we are going to use the template for the small white circles, now it can detect only the white small circles from the input image. But if you see closely, you will notice that the thickness of the bounding boxes is different. This is because we have removed duplicate bounding boxes using non-maximum separation. And if you check your terminals, you will see that the number of matches found after NMS is 4. And that's it. We will have detected all the white circles in the image using template matching and remove the duplicate bounding boxes using non-maximum separation. Here we can see the new image of a chip where we can see multiple type of objects are there in a single image. Now we have to find this return code as a template to generate the template to finding with the input image. Now this one is again your new template we have to find from your input image. This is your component 3. We have to find this image also in your input image. So we are going to analyze multiple images as a template image, and you have to find this multiple template from to detect in your input image. Now what we have done? We have done the template matching technique with the all coordinates of x and y with each and every template and finding this template with maximum separation units. Then you can find these all templates making the green squares in your input image, yellow squares for the different image, red squares for the different image. In this way you can find the different template in your input image. This is again the main multi-template matching technique where we can find all the diamonds from this card. To detect multiple object template using OpenCV and CV2 match template, we need to filter the result matrix generated by CV2 match template. Like so, calling CV2.match template results a matrix that is following spatial dimension, width image shape and template shape plus 1. Height, that is image shape plus template shape 1. We then apply the NP-where function to find all xy coordinates with a normalized correlation coefficient greater than our present threshold. This threshold steps allows us to perform multi-template matching. The final step, which we will cover in this chapter, and apply non-maximum separation to filter overlapping bounding boxes generated by the NP.where filtering. After applying this step, our output image will look like the following. Here we can see the multiple template matching can see in the OpenCV function they are overlapping and non-overlapped. All the diamonds are going to perform with the blue boxes with template matching. Why did we obtain duplicate detection? As explained above, CV2 template matching returns a 2D matrix having the dimension of the input image, one cell, and thus the similarity score of each input has image pixels. Therefore, if an object is detected in one location, all surrounding pixels will most likely have the same similarity score and thus considered as another object top left corners. To tackle this issue, we will sort all detections by decreasing matching values. Then we will choose whether or not to validate the detection. We validate of detection if it is not overlapping too much with any of the already validated detection. Finally, we determine that two detections are overlapping if the intersection over union of their boundary boxes is above a given threshold. This process is called non-maximum separation. Here is a visual expansion of what intersection over union, IOU. That we can say that IOU has given the formula area of overlap divided by area of union. In the template matching, computer object detection matrix on various image to choose hyperparameters, template matching threshold and non-maximum separation threshold. For now, we can simply increase the threshold for component 2. Here is the code for component 2 and we have to make the component colors with grayscale level 0 to 255 and then template matching with the hyperparameters we have done. Again, with this image we can see the hyperparameters are connected with the template matching and we could find all the templates in our input image. We have achieved object detection with template matching by defining at least one template for each object. The more templates you have for one object, the more your recall will be high and your precision low. Using OpenCV template matching method on the image for each template, considering that each pixel having a similarity score above a template threshold is top left corner and the object with these templates height, width and label. Applying non-maximum separation is to detection of object and choosing the template threshold is improve your detection accuracy. As we have defined the different types of template matching technique where we are using NMS, normal simple template matching, where we have used the multiple technique of multiple template matching technique and finally hyperplane matching techniques. So these type of techniques are going to use this template matching and used to go the object detections. So what we have done throughout our in code or OpenCV code, that we are concluding this lecture with this. So first, you have done the single template matching, where you have to find the coordinates of x and y. You have to convert your template in your grayscale images. You have to convert your input image in your grayscale images. You have to follow the left to right approach. You have to follow top to bottom approach, and then find the matrix and the maximum matrix covers in your input image. Then you can find this single template matching technique. The another, we have used the multiple template matching technique. Whenever you go to use this multiple template matching technique, you have to follow multiple templates, height, width, scores with x and y coordinates. Now you have to find all these templates matching with left to right and top to bottom approach. Then we have the find the matrix or maximum matrix that could find with these locations of your multiple matrix multiplication, and then you find this your all multiple matching can be techniqued with your input image. The third one is you performed with non-maximum separation. What could non-maximum separation can done? The non-maximum separation is going to used for the overlapped image, or if the dimension of the similar or same type of object can be different. If you find circle, so the circle height and width of the same circle can be big or can be small. So here we cannot detect the circle over all your images. So we are going here, this issue can be done or solved by your non-maximum separation. The fourth one is hyperplane, where again this overlapped images or the same images with the different dimensions are coming up with you. Then we have to use this hyperplane images, and this hyperplane images can be opted as your template with matching with the x and y coordinates. When you are going to match this x and y coordinates with the hyperplane, and then we are considered it as a template matching techniques for your input image. In the chip method, you can see we have to map multiple objects as a template with your single image. So we have done it properly with your OpenCV concepts. So there is the non-maximum separation, single, multiple template matching technique are only with the threshold values improvisation detection with the accuracy. We have to find the optimized threshold for matching these techniques, and in this way we have done all the types of non-maximum separation, hyperplane, single and multiple template matching techniques with threshold values efficiently done with the OpenCV code. Thank you.